There's not necessarily a torque specification for this, but it is best to tighten it in a crisscross star pattern. We have our compression set up as well. I think I'm going to omit putting the bottom plate in since we've already seen how that works. Plus it's kind of tough to get it up. It's really hard, really no way to grip on it. But we will install the upper joint. So this is your 100 kilonewton compression bedding adapter, or compression bedding joint rather, whereas this is the compression bedding adapter. So for any of the 100 kilonewton setup, whether it's the compression bedding adapter or your universal joint, which is right here, as opposed to one of the nuts, the load cell nuts, you will be using this rod, essentially so it can pass through the existing load cell. So this load cell can remain as you put the lower capacity load cell on.
Are there any fixtures that the 100 kilonewton load cell has that does not have, the other one doesn't have? What can work with?
So I think as it is right now, the 3-point bending fixture is rated at 100 kilonewtons. That's not saying you couldn't use the 300 kilonewton load cell, though I'd recommend putting a software limit in there. And that would just be to kind of not have to put this configuration on, but you would be losing a little bit of resolution and sensitivity down in the lower force regimes if you're using the higher capacity load cell. And use the rod. So either before or after we have the fixture attached, we do need to attach the cal cable and the smaller capacity load cell. So remember to do that, we need to turn the frame off. Yeah. Thank you. So between each load cell and cal cable, there's an extension cable. I tend to use the same extension cable between the higher capacity and the lower capacity load cells. So we'll disconnect the extension cable off one. each of these cowl cables have labels on them, so as to not get them confused. Hop back here just a second. So they kind of connect. I didn't go over this earlier. There's a little sliding collar that you slide back to disconnect. When you're connecting them, they'll pop into position. So we have our lower capacity load cell connected. We can turn the frame on. So something to note, we talked about earlier with the nature of the cowl cable, the nature of the load cell, how all the data is kind of connected, or sorry, stored in the load cell, and how that when we turn the frame on and off, all that data is erased. Every time you change a load cell, or every time you turn the frame on and off, you have to do what's called an e-calibration procedure. So this can be done either on the software or off the touch panel itself. So if you don't do this procedure and you try to start a test, it will kind of give you a little warning. But right now you see this little, it's obvious to everybody, little exclamation point and a yellow triangle saying force ecal. Hit that once, ecal system, go okay, yes. And essentially what this is about a 30-second procedure writing the information from the cowl cable to the frame itself. And again, this can be done on the controller or the software, and we'll show you in the software when we get to it. All right, and it'll blink and kind of show around 0 when it's finished. All right, so that's our compression setup with the 100 kilonewton load cell. I think next we'll switch to the 3-point bending apparatus because that employs the compression joint as well. So what I'll do is I'll remove the compression plate. So for the 3-point bending apparatus, it actually has its own little centering pin. And in addition to the centering pin, there are 2 bolts on either side that go right here into the table. Sorry. And if you don't have them already included, I think on the other instrument over there are your Allen keys to bolt and unbolt certain aspects of this. So we had the compression and bending adapter that was kind of associated with the compression plates, which had the thread on one end and a thread on the other end. This is a little bit different of an adapter in that it has thread on one end and a push fitting on the other end. And essentially how it works is that the loading nose right here has a little recess. It fits in here and a set screw is tightened. So something kind of important in the setup of this 3-point bend apparatus is to make sure that the face of the loading nose and the face of the support rollers are parallel to each other. Something that I like to do is kind of keep this push fitting a little loose so that it can rotate. I'll bring it down a little bit. And then use the supports to kind of sandwich the loading nose, making sure they're parallel to each other. So when the nose is in its downward position, that's probably a good time to set your limit switches. And the idea is that when doing a 3-point bending, if for some reason the brake detect wouldn't activate, because there is a brake detect in the software that detects a drop in force, if that were to not activate, you wouldn't want the nose to recess down and collide into the bottom of the 3-point bending. So depending on the deflection of your sample, and again, unless you have a high deflecting sample, halfway up and down between the height of the spans is probably a good place to set your bottom limit switch. And that's pretty much it for the 3-point bending apparatus. Any questions so far?
I have a
question not related to the 3-point band.
Sure.
Are there grips for the 100